So the next talk is given by Bo Yang from the University of Tokyo. I think he will talk something regarding EHMI and also the combination of computer vision. So let's start.
Hello everyone, this is Yang from the University of Tokyo. Today I would like to introduce our research. The title is Influence on Drivers' Understandings of Systems by presenting image recognition results. First, I will introduce the background and the goal of the research. Level 2 automated driving systems are applied to assist drivers to perform driving tasks, while drivers need to take the responsibility to monitor the systems and keep driving safety. They are requested to pay attention to surrounding traffic situations so that they can take over driving tasks if an emergency event occurs. However, highly automated systems may induce drivers to over-trust on systems, which may induce traffic accidents. Therefore, it is important for drivers to make decisions and act based on correct understandings of systems. A correct understanding of systems can be summarized as a rich structure reflecting users' understanding of what the system contains, how it works, and why it works that way. However, previous studies reported that drivers could not obtain a correct understanding of systems without any necessary support. For example, 70% ACC owners did not know the accurate meanings of the warnings from vehicles about system limitations. About 40% users do not read the owner's guideline, while the rest will read only half of it. Meanwhile, it was reported that risks that were not experienced would fall out of drivers' consciousness. It was reported that the experience of risky scenario after correct explanation in advance might help drivers obtain correct understanding of systems. It was found that it might be effective to present the limitations of systems for safer driving operations, and it was observed that drivers understand ACC better and brake faster when TTC and time headway with a preceding vehicle were displayed. Meanwhile, drivers performed better in takeover situations when the uncertainty of the system were displayed in real time for drivers. According to previous studies, it is possible that human interface that presenting potential risks continuously can help drivers understanding on systems. Therefore, this study will propose an HMI which presents the recognition results of the system directly to drivers. Meanwhile, driving simulator experiments will be performed to evaluate the effectiveness of the proposed method. The proposed HMI will provide the results of the object detection for forward images in real time. It will be displayed with a head-up display fixed on the dashboard. As shown in the figure, the results are displayed as bounding box surrounding the objects which can be recognized by the system. Drivers can understand which objects are being recognized or overlooked by the system in real time. TensorFlow Object Detection API and a pre-trained detection model were used in the system to verify whether drivers could understand the recognition capability of the system or not. The model was trained to be able to recognize car, bus, and truck, while could not recognize motorcycle and panel. A driving simulator was applied, and the Level 2 automated driving functions, ACC and lane keeping systems, were simulated. 18 participants attended the experiment, and the experiment was performed with approval of the university. 3 types of potential risks and 2 types of apparent risks were prepared. Potential risks involve objects that would not directly lead to accidents but were hard to be recognized by the system. Apparent risks involve the same objects where the object would appear on the lane of the eagle vehicle, which would cause accident if no intervention performed by drivers. There were 3 lanes on each side in the first 3 quarters of the scenario and 2 lanes in the rest. For the part with 3 lanes, the eagle vehicle traveled on the second lane, and the potential risk appeared on the first lane. For the part with 2 lanes, the eagle vehicle ran on the first lane where the apparent risk occurred. During the experiment, lane change was not allowed unless emergency events occurred. Here are 3 potential risks. A vehicle suddenly enters the intersection from non-parameter road, and the second one is undetected pylon, and the third one is undetected motorcycle. And for the 2 apparent risks, the first one is vehicle suddenly enter the lane of the eagle vehicle, and the second one is the existence of undetected pylons. Here is the video. First is the car suddenly enter from the no-parameter road. It's the first potential risk. And the second potential risk is undetected pylon. And the third potential risk is the undetected motorcycle. And this is the apparent risk. It's a vehicle suddenly enters the lane of the eagle vehicle. And the second apparent risk is the undetected pylons on the lane of the eagle vehicle. 18 participants were divided into 2 groups. One group drive with HMI and one group without. 3 questionnaires were applied. The questionnaire A was used to obtain the basic information, including driving experience of the participant, and the questionnaire B was applied to evaluate drivers' knowledge and understanding of the systems. Here comes the results. The time to intervene was defined as the time lag between the occurrence of apparent risk and the timing when drivers intervened. It was found that no significant difference exists between the 2 groups. According to the feedbacks from the participant, it was considered that some participants were observing the display when apparent risks occurred, which might result in a delayed reaction even when they realized the risks. For the questionnaire on the recognition ability of the system, it was observed that drivers' understanding of the recognition of the system for motorcycle, pylon, and bicycle significantly improved by HMI. It was considered that displaying potential risks continuously may help drivers keep aware of the existence of potential risks. For the questionnaire on the safeness of the system, it was observed that drivers' understanding on the actions of the system for bicycle and motorcycle significantly improved with HMI. So finally, the conclusion. The human-machine interface was proposed to improve drivers' understandings of Level 2 automated driving systems by presenting the real-time image recognition results of the system to drivers. Driving simulator experiments with 18 participants were performed to analyze the influence of the interface. The results suggest that drivers' understanding of the system might be improved by applying the proposed HMI. Meanwhile, presenting potential risks might help drivers keep aware of the existence of potential risk. So this research was a part of the project entitled HMI and User Education for Highly Automated Driving, supported by the government of Japan, SIP, and funded by NIDO. It was also conducted based on Germany-Japan Research Cooperation on Human Factors in Connected and Automated Driving. Thank you for your listening.
Hello, I am Romy Mikulinski, the head of...
Thank you very much for the very nice presentation. And I already seen Bo Yang with us. So I will invite you to raise your questions. In the meantime, I have a small question. So I think it's really important to have some mechanism to show the vehicle drivers that some AI systems are not perfect. And in your study, you mentioned that you used case studies around 18 participants, and I just had a look about the age range. They are quite young, actually, 20 to 25 years old. So I was wondering if you have more participants, especially with the older age, do you think the result will be different?
Actually, it's caused by the coronavirus. We can only have the students from the university to attend our experiment. So if we cannot say in 100%, so I think maybe the age, if we have more participants, maybe the results may be different. But I think from this study, we can know that if we tell the participant the system is not 100% with the HMI, for example, we just display something to them. This can remind them the system is not maybe not 100% correct. So in this case, I think even we have more participants, or we have maybe males or females, or maybe the participant over maybe 60 years old, I think maybe we can still have better results with when we apply HMI, I think.
Yeah, thank you very much.
Yeah.
So I think we got another 2 questions. So probably Chen Peng can go ahead, then we come to Hailong.
Thanks, Ha. And thanks for the presentation. So my question is about the video stimulus you used in the experiment. So I saw some, these cars in front of the ego vehicle had some, very aggressive or some dangerous behavior, like the cut-in behavior was quite aggressive, was quite sudden. So I'm a bit curious, like, how did you get this? How did you model this? How did you implement such behavior in the stimulus in the video? Did you get that from the real driving data, or you just manipulate it in a very more aggressive, more noticeable way?
Actually, we just want to have have the vehicle enter from the no permitted road in sudden, because if the vehicle moves slowly inside, we cannot expect any difference, because we have only maybe 10 nine participants for one group. So if we have the vehicle enter slowly, maybe we cannot expect any difference, I think. So if we, for example, if we have many participants, maybe we can have the vehicle slow down or like that. But for the goal of this research, we just said the vehicle enter suddenly.
Makes sense. Thank you.
Thank you. So for the sake of time, I will just repeat the question from Hailong. So his question about the bounding box, because the bounding box can only detect some road users. What if the bounding box ignores some other road users and distract the driver? So do we have a comment on it?
Sorry, can you repeat it? Because it's really heavily outside. I just missed some words, sorry.
So what about the distraction from the bounding box? Do you have a comment? Yeah.
Okay, I will check from the chart, sorry. Oh, so you mean if we display some, say, bounding box on the display, it may, how to say, have the visual distraction. Visual distraction is means that, right? Yeah, in this case, because in this study, we did not consider the other user, for example, the pedestrian. We just consider, how to say, for the motorcycle, I think ignore this. It can. Let me consider.
So, which means if you show the bounding box, the green bounding box, maybe the driver focus on the bounding box.
Oh yeah.
Yeah, that maybe is a problem, I think.
Oh, you mean the driver will always look at the
display, look
right?
at the bounding box.
Actually, in the experiment, some as I show in the results for the time to action, time to interval. So yeah, I think you can say there's no significant difference between the two groups. So according to the comments, this one. So according to the comments from the participants, they said they are actually watching the display when the apparent risks happen. So now we are considering how to display this kind of result to them. So now we are doing another experiment. We just just use not use a display on the dashboard. We just consider in the future maybe we can display something on the windshield of the vehicle, and we are doing this kind of results. Yeah, I think in this case the drivers will always look. Now we use the head-up display. We expect they can look forward, but sometimes they watch the display. So if we display on the windshield, they will always look forward, just like we are driving the normal car. So I think maybe the results can be different.
Okay, thank you.
Yeah. Okay, thank you. So maybe I think we have a 4-minute break, but I think I can just squeeze one more question from Professor Zesta. Then we continue.
Okay, thank you very much. My question is, what is the effect of this undetected object on the trust? What do you think? Because there might always be undetected objects, and then people might not feel very trust the system very much.
So you mean for the thank you for your question. So you mean for the influence of undetected object on the trust, right?
Yes.
Okay. So I think from the results of the questionnaire, we can say if the participant they can observe that the system cannot detect something in real time, they will consider they can be reminded that the system is not 100% correct. So I think this may reduce the possibility of overtrust on the system. So Hailong, can you change it to the next page, next slide? Yeah, then you can see from maybe from this questionnaire, you can see we compare the groups with HMI with the HMI. We can know that if we use the HMI to tell participant the system is not 100% in real time, they can have a better or more accurate trust level on the system, I think. So I think that by providing some by providing the real-time recognition result to the participant, it can make them have it can reduce the possibility of overtrust.
Okay, so thank you very much again for the presentation and also the questions. I think we can move on for the next presentation.